This video is on average value. All right, so on the screen you see a formula for the average value of a function f of x on an interval ab. So it says that f average is equal to 1 over b minus a times the integral from a to b of f of x dx. All right, so first let's see how this formula works. So we'll do a problem, and so problem 1 is going to be find the average of f of x equals x squared plus 1 on the interval -1 to 2. So from x equals -1 to x equals 2. Okay, so it's very easy to use the formula. We just plug things in, so we get f average is equal to 1 over 2 minus -1 times the integral from -1 to 2 of the function x squared plus 1 dx. To do that, we just simplify 1 over 2 minus -1 and get 1/3. We do the antiderivative of x squared plus 1. That's 1/3 x to the third plus x. And we evaluate that from -1 to +2. So we plug in -1 and subtract. Oops, that 1/3 should stay 1/3 and not become 1/2. So we get 1/3 times now 1/3 times 2 to the third plus 2 minus 1/3 times -1 to the third plus -1. And now we simplify that. So we get 1/3 times, this will be 8/3 plus, and we'll go ahead and make that 6/3 to get a common denominator, minus, and now this will be -1/3 plus -3/3 to get a common denominator. And so we'll come up here and say, okay, that's 1/3 times now 14/3 minus -4/3, so plus 4/3. That's 18/3, which is 6. And 1/3 times 6 is then 2. Okay, so we get an average value of 2. The formula is very, very easy to use. Any textbook should go through the derivation of that formula, but basically what it does is it corresponds to the integral adding up all the y values, so it's saying add up the y values, and then it's times 1 over b minus a because it's like we're dividing by how many there are. It's more related to a weighted average and a Riemann sum, and it would be worth looking through the derivation of that in a standard textbook on calculus. It's not required to do that to use the formula. We need to know what the formula is, and we need to know how to apply it. It is worth thinking about why we would be using an integral for average value. So if we were to calculate the average test score for this class, let's say this is a class of 30 students. If I were to calculate the average score on the midterm exam, all I would do is add up the 30 scores and divide by 30. I would not use an integral. What this average value formula is for a continuous function from A to B. That would be something like if I said, okay, what is the average temperature this afternoon? So let's say the average temperature from noon until 3 p.m. Well, between noon and 3 p.m., there's technically an infinite number of temperatures because every instant has its own temperature. If that's a continuous function, then this formula would calculate that. Okay, so this is talking about something where we're calculating the average of an infinite number of y values. There's something called the mean value theorem for integrals. Okay, so the mean value theorem involving the average value. And so we want to talk about that real quick. So it says that if f is continuous on AB, then there exists a C in AB such that f of C equals f average. and f average is as defined above, 1 over b minus a times the integral from a to b of f of x dx. Okay, so if we look back at the example before, we said that the average value is 2 for that problem. What this mean value theorem indicates is that there's a c, so the c here that we're talking about over on the right hand side of the screen, that's an x value between -1 and 2 in the previous problem. There's an x value there where the y value of the function, so f of c, where the y value is equal to the average value. So if this were temperature, so if between time -2 and time -1 and +2, between those times, so maybe -1 is like 11 a.m., maybe 2 is like 2 p.m. So between 11 and 2, if the average temperature is say 2 degrees Celsius, at some point within that time period, the temperature was exactly 2 degrees Celsius. If the function's continuous, then that has to be true. Proof is related to the mean value theorem that you learn in Calc 1. But what we want to do is a problem based on that. So problem 2 is going to be find C such that f of C equals f average from problem 1. Okay, and so we'll work the solution in blue just to kind of clear it out. But we've got f of x equals x squared plus 1, and on the interval -1 to 2. Okay, so we've got f of x equals x squared plus 1 on the interval -1 to 2, and we know that f average is equal to 2 from the above problem. So we know that f average is equal to 2. Okay, so all we're trying to do is figure out what c do you plug into the function that would get you the average value. So we know that f of c is going to equal f average somewhere between -1 and +2. So f of c is c squared plus 1. F average is 2, and the problem is now just to solve for c. So we subtract 1, and we take the square root. So we get c is plus or minus 1. In this problem, both of those are in the interval -1 to 2. So we have two answers to the question. C equals -1 or C equals +1. At both of those x values, we would have it such that f of -1 is 2 and f of 1 is 2. We can check that quickly by plugging in. Graphically, we want to look at what happens there. So f of x equals x squared plus 1 is a parabola shifted up 1. At -1, the y value is 2. At +2, which is the end of the interval we're talking about, the y value is 5. Extend that up a little bit. And then the vertex of the parabola is at 0, 1. So the graph looks like this. Okay, because we know that f of c is equal to the average, which is equal to 1 over b minus a times the integral from a to b of f of x dx, we can also write that b minus a times f of c is equal to the integral from a to b of f of x dx. That's just by taking the two outer parts of the equation I have on the top line there and multiplying by b minus a. So I would take the b minus a from the far right hand side and multiply it over and get b minus a times f of c is equal to that integral. Okay, if we look at -1 and 1, which is where we found the c values from above, the height of the graph there is 2 because that's the average value, and that's what we get when we plug in. If we look at that rectangle where the height is at the height of the average value, so this is the y value here is 2, but it's f average. The height is the average. The base goes from -1 to 2. That area is actually this side. And so this is the blue rectangle that I've got drawn in the picture. That's equal to the integral from a to b. So the area of the blue rectangle is equal to the area under the graph from -1 to 2. You'll see on the worksheet that goes with this video some problems where you're asked to draw a rectangle where the area of the rectangle is the same as the area under the curve, and this is what it means. So this is what you get from the mean value theorem for integrals. Okay, so this is a quick video, but basically 3 things to be able to do. One is we need to be able to compute the average value using the average value formula. That can be very simple or very difficult, depending on how difficult the integral is to evaluate. But basically the new part is we're just multiplying by 1 over b minus a. From there, we need to be able to get the guaranteed value in the mean value theorem. So we need to be able to find c in the interval such that f of c equals the average. That's basically you just plug c into the function and set it equal to the average value and solve for c. And then graphically, we need to be able to demonstrate that by drawing the rectangle where the height is the average value. It goes from A to B, so it goes from the far left of the interval to the far right of the interval. That rectangle's area would be the same as the area under the graph from A to B. All right, that's it for the average value video. Thanks for watching.